Okay, we have retained integral from the Vienna integration bee 2024, number 22. We have the integral of 2x squared plus x plus 4 over x cubed plus x squared plus 4x plus 4 dx. Now to get started with it, the first thing I notice, the denominator is clearly factorable and we can definitely do partial fractions on it. But I think for me, I'm going to try to avoid the partial fractions. We can do it another time, but I like to put it off for another day. So in order to avoid partial fractions on this, and my way is not going to be much better. I think it's probably about the same. I don't know, but I'm just going to avoid it anyway. So I'm going to try to force the u substitution to happen. For my u substitution, let's try to make, I'm going to kind of try to force this to happen and make my u substitution on the whole denominator. And then I'll take a derivative to get du. That's going to be 3x squared plus 2x plus 4 dx. And then what I'm going to do is create an integral that sets this up exactly. So what I want is I want a numerator to be all this stuff. And then I want the denominator to be our u value, which is all this. And so by creating an integral where we have just du over u, we can just do this one right now because this is just going to become natural log absolute value of all this stuff. And that was really easy, except now we've totally changed the problem, right? Because this numerator does not match this. Well, what I want to do is create a second integral that's going to make this all work. So let me get rid of this because we've already finished this first integral. And so for the second one, we want the same exact denominator, of course. And then in order to get this back where we're not changing it, first looking at 3x squared, to get back to 2x squared, I'll subtract just an x squared. Then looking at the next term, to get from 2x to x, I need to subtract an x. So we'll just have plus x, right, because we're subtracting with the minus. And then we're okay with this 4. This already matches. So here's our new integral over here. But now for this, now what I'll do is factor. So if I factor an x out of this, we have x over x plus 1. Here I can kind of group it and do the same thing on here. So like if I factor what's in common here, I can factor out an x squared on just that part. And then it's going to be x squared times x plus 1. Here I can factor out a 4. And then we have 4 times x plus 1. But then we've got an x plus 1 in everything, so we just cancel all those out. And what we're left with is going to be just x over x squared plus 4. But then this one's going to be easy with a u sub. We'll do a quick u sub right here. U for the whole denominator. Du is just going to be 2x. I can multiply in a 2 and divide it out front. And so now what we have here again is just our du over u situation. Now, one thing I should have captured on the board was when I factored this, this came out to be x squared plus 4 times x plus 1. But this is the same thing as this, so I can write this factored like this up here. And now that we have multiplication inside the natural log, I can break this up with log properties and write it as natural log x squared plus 4. I dropped the absolute value because x squared plus 4 is always positive. I'll keep it on this one though, because we don't know on x plus 1. So this one will be natural log absolute value x plus 1. Here we'll have minus 1/2, and this is just going to be natural log, because we have du over u, we're integrating, so this is going to be natural log absolute value. Again, I can drop it on this, and we have half natural log x squared plus 4. But now we've got the same thing right here and here. We're subtracting a half. Here we have one copy of it. And so putting this together, for my final solution, we have 1/2 natural log x squared plus 4 plus natural log x plus 1, add a plus c, and that's it. Okay, there you go. Good one today from Vienna 2024. Thanks everyone for watching. Have a good day.